Welcome back to All This Math. This is Professor Parker, and for this next lesson, we're going to talk about sigma notation and finding the sum of a series, right? All right, but before we do that, since I got my old head, Carter G. Woodson, on my t-shirt, this is my Carter G. Woodson t-shirt, The Miseducation of the Negro. It's March of 2023 at the time while I'm recording this video. Of course, Black History Month officially just ended, but if we know any better, we know that Black History Month can never really end because we should really be celebrating and studying and planning and strategizing, around our history 24/7, 365. So really, Black History Month really is like a halftime where we reflect on what we learned in the last 12 months and what we're about to get into in the next 12 months. So it's really an ongoing process. It's not like a holiday, really, unless you're into that. But, I'm a little more serious about it. So it's an ongoing thing. But what I wanted to do is I pulled some of my Carter G. Woodson collection from my library out. And I got a few joints. This is a Carter G. Woodson, father of African American history. This is a joint for like the youth. This is a good joint right here. Found this at a library, or maybe I bought it from a library or something. This is one of his. Actually, I believe he wrote this before he wrote The Miseducation of the Negro. This is The Education of the Negro. I still need to finish this. This is The Education of the Negro, right? An essential preface to understanding The Miseducation of the Negro, which is his most popular book, probably. And speaking of which, The Miseducation of the Negro. All right? So we got that. And then some other less known, more obscure titles that he authored. A Century of Negro Migration. Don't forget, Woodson was a historian for real. A Century of Negro Migration. Right? We got that. And we got, a compilation. African Myths and Folktales. I think my dad bought me this. Yeah, shout out to my dad. He bought me this for Kwanzaa one year. All right. Then we got The Negro in Our History. The Negro in Our History. All right. Woodson did a lot of writing. And then I got this. I got to be careful with this. This is look at the binding on that. This is old school. Negro Orators and Their Orations. Negro Orators and Their Orations by Carter Godwin Woodson. Look at that. That's classic. Can't nobody borrow this joint. Yeah, I keep that safe. And then this is a biography by Jacqueline Goggin, where I learned a lot about Woodson. Carter G. Woodson, A Life in Black History by Jacqueline Goggin. And last but not least, I haven't read this, but this is The Early Black History Movement, Carter G. Woodson and Lorenzo Johnston Green. All right, so I just wanted to, since I got the brother's t-shirt on, just wanted to, show some information, some books that either he wrote or some books that have been written about him. If you would like to learn more about the person who's responsible for starting Negro History Week in February, I believe in 1925, which later became federally and nationally recognized as Black History Month in the month of February, So definitely check out some of those titles. If you ain't get them all, this is YouTube. So just rewind the video, run it back, and just, jot down the titles and then go on your search. And hopefully you'll try to grab them from a Black-owned bookstore. All right, try to grab them from a Black-owned bookstore. Support the hustle. All right. So anyway, let's get to this. Finding the sum of a series. So this big E-looking thing right here. This is sigma, right? This is sigma, right? This is called sigma notation. This is the Greek letter sigma, which symbolizes, or basically it's a set of instructions. It tells us to add everything up, right? And find the sum of everything, all right? So this number down here, I believe this is called an index. K equals 1 means that's the first number that we're going to utilize in the series, all right? We're going to input that wherever we see the variable K. Of course, you see the variable K right here. So, and we're going all the way up to 30, right? So we would input 1 and then do the calculation, right? And then we would input 2 and do the calculation. And then we would input 3 and do the calculation. Then we would input 4 and do the calculation. And you would do that all the way up until 30. And then sigma indicates, or sigma instructs us to add up all of those values. Now check this out. That would take a lot of time. I'm not about to do that on this video. I'm not about to do that, right? Fortunately for us, we have a formula that we can use, right? Which is much more efficient, much more practical, and saves us a lot of time. All right, now this is the formula. I'm gonna write it down because formulas are very important. So the formula that we would use is when we have an arithmetic series, right? Because this is arithmetic, because all we're doing addition. We substitute the number, we're gonna subtract and then multiply, and then we're doing addition. That's an arithmetic series, right? It's not geometric. If it was geometric, we'd be doing something different. But I'll talk about geometric series on another video, all right? But this is a arithmetic series, so this is the formula, right? The sum is basically going to be, I want to say K. We use K because this is the value, right? Actually, no, I'm not going to use K. I'm going to use N. I'm going to use the variable N. N is the number of numbers divided by 2 times a sub 1 plus a sub n. Now, I know that might seem like a little bit intimidating, but, you know, it's just letters. That's all it is. They just letters. You just chill for a minute. Chill, take a deep breath. Don't be intimidated, right? I'm going to explain all of it, right? All of these letters represent something. This represents the sum of all the numbers from when you plug 1 in, when you plug 2 in, 3, 4, 5, 6, 7, so on, all the way up to 30, and then you add up all those numbers to get a sum, right? That's what all this represents. And that's what this represents also. N is the number of numbers that you're going to have, right? The number of numbers that you would have. So because we start at 1 and we go up to 30, that means we're going to have 30 numbers to add, because we're going to have the value we get when we plug 1 in, the value we get when we plug 2 in, the value we get when we plug 3 in, the value we get when we plug 4 in, and so on and so on and so forth until you get up to 30. We would have 30 values, right? That would have to be added together. So our N is 30. Now, a sub 1 is the value we get when we plug the numbers in, right? But a sub 1 is the first value. 1 corresponds or indicates that we're dealing with the first number, which is 1. Now, a sub n is always the last number, right? A sub n is the value we get when we plug in n, which is considered to be the last number. So what I need to know right now in order to use this formula is I need to know what a sub 1 is. I already know what n is. N is 30. I know that. N is 30. N is 30, right? But a sub 1 is the value we get when we plug the first number in the series in, right? Or the sequence, rather. So watch this. A sub 1 is equal to all of this with a 1 plugged in place of the K. That's it. A sub 1 is going to be equal to this with a 1 plugged in here in place of K. So I'm going to say 9 plus 13 times 1 minus 1. And I don't need the brackets. The only reason I had the brackets here is because of the sigma notation. I wanted to show that all of this, the value of all of this together should be added. Each of these should be added, right? But I don't need it for here. So now I can just use order of operations, right? That's the purpose of us learning order of operations. And hopefully we did learn order of operations. So I could distribute, but I'm gonna just use order of operations. 1 minus 1 is 0. So now we got 9 plus 0. And where does 0 come from? 13 times 0. Any number multiplied by 0 is 0. So that gives us 9. So my a sub 1 is 9, right? Now I got to find a sub n, except a sub n is the value that I get when I plug in the last number in the series, which is 30. So instead of saying a sub n, I'm going to say a sub 30, because a is the value I'm going to get when I plug 30 into the expression. So watch this. Actually, I'm going to put it right here. A sub 30 is equal to, again, I'm doing the same thing, except instead of a 1, it's going to be a 30. Instead of a 1, it's going to be a 30. Instead of a 1, it's going to be a 30, because I got a 30 right there. Say I had a 1 right here, I got a 1 right there. I got a 30 right here, I'm going to have a 30 somewhere around here. See, math is all about patterns. Once you get the pattern, then you're going to be cool. Right? Oh, that's going to be a large number. All right, that's cool, though. So we got 9 plus 13 times 29. Right? Now, remember, follow order of operations as much as you may not want to. I know some people are going to look at this and going to be tempted to do 9 plus 13. I know, because even I get tempted sometimes. I get tempted to disobey the rules, but follow the rules and good things going to happen. All right? So 9 plus 13 times 29, 13 times 29, this is a product of 377. So that's 9 plus 377, right? So 9 plus 377, a little math trick. Since 9 is so close to 10, I can do, it's called, rounding and compensating. Some textbooks may call it. Treat this like it's a 10. Do 377 plus 10. That'll give you 387. And then subtract 1 from 387. Because 9 is 1 less than 10, right? So really, that's going to give you the same result, right? So this is going to be 386. All right? So I know a sub 1 is 9. I know a sub 30 is 386. And a sub 30 represents a sub n, because n represents the value, the last number in the series. Last number in the series is up here. The first number in the series is down here. Last number in the series is up here. First number in the series is down here. All right? So now I'm about to do this. Now I go back to this formula. Now n, how many numbers I got? I got 30. So I'm doing 30 over 2. And then I'm doing a sub 1, which was 9. Boom. And then I'm doing a sub n, which is really a sub 30, which is 386. So just plugging the numbers in. Just plugging the numbers in. That's all I'm doing. Now I'm going to simplify this fraction because I can, because 30 is divisible by 2. So 30 divided by 2 is going to give me 15. So I got 15. Inside the parentheses, now I'm doing 386 plus 9, or 9 plus 386, but addition is commutative, so the order doesn't matter, right? So 386 plus 9, I'm going to do the same trick. I'm going to treat this like a 10. 386 plus 10 is 396. Then I'm going to subtract 1 from 396, and I'm going to get 395, right? So now I got 15 times 395, all right? So 15 times 395, right? 15 times 395, I did the math earlier, is 5,925. So this is the sum of all of the values of this expression from 1 up to 30. So without this formula, right? See, the formulas, people just, recognize patterns. Mathematicians, historically, our ancestors in ancient Africa, ancient Kemet, different parts of Africa, on the continent, West Africa, Central Africa, wherever they were, right? They arrived at different formulas. They recognized patterns in nature and patterns in work they was doing. And that's where these formulas come from. Otherwise, we'd be sitting up here doing a sub 1, we'd have got 9. Then we would have plugged the 2 in. We'd have got another number. We'd have plugged the 3 in. We'd have got another number. We'd have plugged the 4 in. Got another number. Plugged the 5 in. Got another number. And don't nobody got time for all that, especially when you have a nice, neat formula that you can use. But we can't be scared of math, right, when we're actually given formulas that actually make things easier. In our minds, sometimes we see letters and we see, different formulas, and we get intimidated. We think like, oh, this is harder. But it's actually making things easier if we just relax and just allow ourselves to, receive the information, So it's really a state of mind that's going to enable you to actually see the benefit of utilizing formulas. So just a little bit of work on finding the sum of a series, evaluating using sigma notation, and, just something I wanted to go over real quick. I went over, this is one of the problems I went over in a tutoring session I had not too long ago, and I just wanted to share it with the rest of y'all because it was a good problem. All right, so go get some practice. All right, if you're doing this in school right now, get some practice, right? Because the videos are helpful, but you got to practice. You got to practice on your own. It's not enough to just watch a video. I don't know, maybe for some of y'all it is, but even that, you want to retain the information. You want to retain it. So even if you could just watch the video and be like, okay, I get it now, that's cool, but you want to retain it because you might need to take a class where you got to do this again in 2 or 3 or 4 years. And because you didn't get the practice, you're going to be totally lost. And it's going to be as if you never learned it 2, 3, or 4 years from now. So definitely go get some practice. Do yourself a favor. Go get some practice and, so you can get mastery. All right. And also, study the brother. Study Carter G. Woodson. Look up some of his work. Read his work. Definitely, I highly recommend The Miseducation of the Negro. We all should read that. It's a very important piece of literature that is very applicable to today's society. So go check that out. Get some practice on these, and I'll see you on the next video. Peace.